What we'll be doing now is we're going to get into the terminal and mostly demo out some of these commands. And more specifically, what's covered in this video really is almost every git commit or git command that you'll actually ever need to know done in the terminal. It takes less than 25 seconds to actually create a commit and then push it out to your copy, your fork that is over in GitHub. And that's shown at a couple of different places in the video at varying time lengths, depending on how much time I'm taking to really explain what's going on. Really, this can capture all of it, and these are all handy things that you'll want to know in order to doctor a couple of different things, and you can't do that with the graphical tools sometimes. And yes. Alright, hello and welcome back. In the last video we covered the buttons for the terminal commands that exist inside of RStudio, but the reality is that you're going to need to live inside of the terminal for some of this, and in fact it can be a lot faster for you. So let's go ahead and jump right into it. However, what I first want to go over is that commit message best practices that we were talking about earlier. Here we are looking at that git2 branch that we created in the RStudio example. And we can see, I'm just going to go ahead and refresh this real quick. We can see the file or the directory that we added that contains the file hello world and the commit message that we submitted. As you can see, a quick tooltip overhead. If you keep it less than 80 characters on that first line and add additional white space underneath it, then you can add as much detail you want at the bottom and keep everything nice and summarized up at the top. Now, after we click on this, we can see the actual SHA-1 hash, the unique identifier for that commit that exists inside of that ledger. And we can also see the shortened 8-digit, or the first 8 digits of the commit that was one behind it, or at which point in the ledger did this commit that contains these changes actually change from, or its parent commit. You can see who did it, you can see when it happened, and so on and so forth. Now, what we're going to do here is I am going to go ahead and use the SSH URL. And this is for a good reason. It will ask you for your username and password all the same. The difference is that you can configure Git to cache those credentials, so that way you only type them in once every single time you have to log in. So let's go ahead and git clone. Now, something interesting here is that I am using my public SSH key that I've generated. You can add these in GitHub by going to your profile icon in the top right and going to settings and SSH and GPG keys. Make sure that you only add your public key, and this way, GitHub knows it's you, and you only have a little key that you can type in instead of using absurdly long passwords sometimes, which is very nice, or can be. Of course, I have a password actually set on my public key for reasons. Now we can see that we've cloned into a mixtures here. Let's go ahead and CD into that. Now let's do a git status, and you can see that it by default cloned origin master, or the main branch at remote origin, which is the name for this this GitHub repo that we have going on. Let's go ahead and switch over to get to here. Now, since we only have one origin or one remote, we need to keep to this syntax without a -B, although the -B can become important later. And we're now able to track that new branch, or that branch that exists at the remote on GitHub that we've named, that is automatically named origin. And we should see our changes and our hello world file all there. And there's our one line. Let's go ahead and add a second line to it. And what we're actually going to use here is a separate editor. However, and it's just a personal thing that I have going on. You can still edit this file inside of RStudio or any editor that you choose. But we're going to go ahead and change it here. And we'll have it print, add a second line. We'll background that. Now, if we type in git status again, we can see which branch we're on, which files were changed, and how different it is from what's going or what's being kept track of at the remote. Currently, we're up to date. So we'll git add that changes hello world.r file. Of course, if you are already inside of the same directory as that file, you don't need to type in all of that. You can cd changes print working directory, and we know that we're here, and we'll git add hello world.r. Now if we git status again, we'll just say, hey, by the way, you've added and modified this file, and I'm now keeping track of it inside of our local version, because our local repository said, okay, I mean, I have this file from the remote, but you haven't told me to actually keep track of any changes to it yet. Now that we've git added at least once inside of our local repository, it's always going to keep track of this file for us. And when we call git add, we're staging it to actually go inside of that commit that'll go inside the ledger. Another way that you can do this is you can do, after you, actually, let's just go ahead and push this. So we're going to git commit -m, added a second line to hello world.r, and it's best practice, once again, to keep this under less than 80 characters. Over here, it'll only show the summary up to 80 characters. So, it's useful as a headline tagger. We've added this into the ledger locally, and now we need to actually push that change. Now, a neat shorthand here is that I can just do git push. And we only have one remote, it's the default origin, and Git already knows which branch we're working in. So the full version of this syntax is you might type in the remote name and then the branch name if you want it to be very specific, or you were in a different branch, or maybe you're pushing to a different remote. But thankfully, we're just only in one thing at a time here, so we can just do git push and it'll automatically handle that for us. And as you can see, it's automatically updated over here. And GitHub saw, oh hey, we've changed something. we know that there's new things there. And here it is. After we refresh a page, it appears. Now, of course, you can write comments and whatnot and what have you. So that's how easy and quick it is to go ahead, create a new change, create a new branch, and pull it all in. We'll talk about bringing all of these things together in another video. I do just want to take a moment now here after the first 10 minutes of actually doing this to say we could have taken some other paths. One thing that we can do, let's just go ahead and completely blow away the local repository that we had. Look, nothing there. All right, something that we could have done instead is we can actually directly clone a specific branch. We can git clone -b, the name of the branch, at this thing, or at this URL, and it's there for us. Something else we can do is we can also add in the name of the directory that we want to clone into. In this case, maybe I just want to call the directory mix, because I don't want to switch around too many branches, or I need to keep multiple copies of multiple branches, and I just want a different directory, right? Now, let's git status. Let's first change into the directory where the Git repo exists. And let's go ahead and take a look. Ta-da! Our changes directory is there. What branch are we on? We're on the Git2 that was actually available from the remote. So that's a really quick and easy way to just work off of one specific branch, or if you're on a new computer or something. Another thing of particular use that I want to point out is that you can actually set these different environment variables for Git configuration. And in particular, I don't want to type in my password every darn time. This should work for both the HTTPS and the SSH versions. I just happen to work inside the SSH version pretty regularly. Now, here's an important thing is we don't want that -- global in there necessarily unless you know that where you're working will never have a Git repository that talks to anything other than like GitHub ever again, right? We can get around that by just using git config -- local instead of global, credential.helper cache. Now, if I go ahead and git fetch again, I have to type in once. Let's go ahead and make another change to that example that we had going on. And I'll use the Vim editor to open hello world and add a comment, blah, blah, comment. We'll git commit -a, once again, well, first, let's go ahead and git status. We know it's modified. What if we went ahead and just did git commit -am added comments? Now, this flag -a is going to tell Git to add everything currently in order to make sure that it's actually tracked. And git status, we can now see we're ahead by one commit, and it took everything I changed at that one point in time and attached this short message with -m added comments. Let's go ahead and git push. If you don't have if you don't have if you don't have SSH keys set up, you should be able to avoid typing your password there. I have extra stuff going on with my SSH key, so please don't worry about that. It will work. And if you actually go to the Git website, which is gitscm.com, everything is fully documented ad nauseum. Almost anything that you could possibly want, or any problem that you've run into, someone else has run into before, and I highly recommend checking that through. Now, one last thing that's important is maybe we want to just create a branch locally. Well, first let's list all branches. We can view everything here, and it says, hey, by the way, you're on Git2. Maybe I want to view all remotes, and Git remote lists all of the remotes. It tells me that there's one named origin, doesn't tell me a whole lot. So I want it to be verbose with -v. And we apparently have read access, which is git fetch, to something we've named origin, located at that URL, and we have write access, which is push. So hopefully that's a real nice, quick, short introduction, and you saw how fast that was. And we will talk about the other things that are all there later. There was one thing that I forgot to do real quick, actually. One more thing that we can do is we want to create a new branch and actually send that to GitHub, right? So we can git checkout -B, and we'll name this git2.3, and it should tell us everything here. I also forgot git log. Typing in git log will give you a history of everything that's going on, and it will also tell you where each of these branches, we have a local one called git2.3 that we just created, and we have the local git2 that we have running around, and of course the git2 that exists over on our remote origin that is over in GitHub. It'll also tell you where everything else is. This is identical to the history button inside of our studio. There's a lot of different viewers that make this look good that also work in the terminal, but that's outside the scope here for now. Please feel free to ask or Google. Scroll with J and K, and you can quit by pressing Q. So we've created this git2.3, and it's important that you know whenever you do git checkout -B, either -B or -b, that it will use whatever the current status of the branch that you're currently working in is. So if I ran git checkout from the branch master, I would end up at a different point in that ledger of commits for everything inside of the repo. Now, let's also go ahead and just create an empty file with touch. Actually, before we do that, I do just want to point out that all of these have help messages attached, and you can access it with --help. Which pulls up the manual page for it. And down here we have git checkout -B, the new branch, and you can also specify a commit to actually start something from. So it's useful to read through these, and once again, you can press Q to quit. Once again, like let's say we wanted to start off. Well, first let's go ahead and make sure that GitHub actually knows that Git23 exists, which it doesn't yet. Let's refresh the page and do Git2. See, only Git2 is there. We want git push -update -u to our named remote origin, and we want specifically to push let's add a change to that branch first. We'll create an empty file with touch called changes example and now git add changes example git commit added example. And what we can do now is git push -u for update the remote with our new branch as it currently exists. And as you can see, it now knows. Our remote here now knows that there's a new branch called Git23. We took our local version, we sent it to the remote version, and it's over on origin as a remote branch. All right, hopefully that covers enough. I have actually forgotten to mention one very important thing. And let's say, let's double check here. Let's say that I actually wanted inside of this Git2 branch to get rid of these 3 commits, or I wanted to revert this commit, or which would put me back at this commit, or let's say I wanted to revert these 3 commits to end up back at this point in the ledger. The simplest and best practice way to do this, let's make sure that we're in the right repository here. We're on branch Git2, and it looks like we're in the right thing. Git remote -v. Yep, looks like we're in the right place. Is we can use git revert. And let's peek the help real quick. Basically, it's a new commit that says, hey, by the way, these 3 other commits that happened, let's just ignore those and reset and fast forwards changes that were done previously. Now, specifically for the example where I want to get rid of these 3 commits, the commit that I want to revert is this one because of the ones that follow. And here's our, will it let me copy it? Yes, so you can click this button to get the full hash sum. You can also click on this and it'll give you the whole shebang. That first 7 digits that help reference everything. I'm going to copy that real quick. We can view the same thing using git log. We can see git2 is over here. Master or the main branch is over here. I don't really want to keep, and I want to take this commit and this commit and this commit, or just this commit and anything following, and make it revert back to what was going on here. So this is the commit that we want to revert, and like I said earlier, we already copied those first 7 digits. The way to do this is with git revert, and we can place this, that 7 digit, or if you want, use the whole SHA-SUM. It's always safer to use the whole SHA-SUM. You can also use some symbolic markers here. So we know right now that our head is at the latest version of that Git2 branch. And I want the 2 before head to also be reverted. So I can use the tilde or shift backtick over here and say, okay, head -2. It's always safer to use that SHA-1 hash because you know exactly which unique commit you're talking about, and sometimes actually counting the symbolic marker difference is like off by 1. So let's commit that. And as you can see, we have an error. It's saying, hey, by the way, we couldn't just revert that. And let's go find out why. We have get status. Now, it lets us know, hey, by the way, you're currently trying to revert a commit. There's some issues there, and it's because we're tracking the file that we added in that commit. If we revert that commit, it gets rid of the file, and gets like, do you really want to stop keeping track of that file? I mean, what am I going to do? As you can see here, it tells you what to do, and it won't tell you this using the button GUI. In a lot of different situations, depending on what IDE or integrated development environment you're using. So I like the terminal for this. Let's go ahead and, well, we know that there's no changes in that, or once we get rid of these 3 commits, we get rid of that file effectively. So we can get RM, the whole directory. We can get RM recursively to include everything inside of that directory. And now we can get status. And it's like, hey, we're looking good. And it's automatically staged the removal of that file. Or, say we had a file that we deleted previously and now we need it back. You, of course, git add a file. Once the head of the ledger has been reset to whichever point in the ledger it was supposed to be at. And it's automatically committed that for us. So let's go ahead and git revert -- continue. It'll let you know everything that's going on. It gives you a nice little handy overview that just keeps track of what you removed, what you reset, and why. We'll go ahead and write that out. That's fine with us. And now we want to git push we can just git push because we only have one upstream remote, and we're working in just the one branch. I kept track of it for us. Can of course do git push remote name branch name if you're working outside of the branch for whatever reason, which happens often. If you need to delete a branch, you can't be in that branch, and so on and so forth. So of course it's completed for us, it's uploaded, and we can go back and check and refresh the page, and there it is. So now when we go back and we look at git log, it says, hey, by the way, we're up here and we captured all of this information that's in here. But remember earlier how we did git diff in order to find out what the difference between the 2 branches was? Well, let's go ahead and git diff what we have in git 2 and what we have in that main branch. And it wants the name of the remote / the name of the branch. Hey, there is no difference. So that's how you roll back a